Silicon is a naturally occurring mineral that has been receiving a lot of renewed excitement, especially in recent years in the agricultural community. It's a mineral that's not typically super plant available in the soil profile, but despite this, it may still be very useful and beneficial for these plants. Alright, so here we are talking about silicon, abbreviated as Si. You can find that on the periodic table of elements. And you may have heard a similar term such as silica, which has an A on the end instead of the ON. And silica is a form or certain forms of silicon, whereas silicon is more referencing the pure element and kind of the totality of that, right? Whereas silica is certain forms, but those forms generally tend to not be very plant available. So I will be referring to this element as silicon. Also, there is another term out there that sounds very similar, silicone, right, which has an E at the end after that N. And that is a synthetic human-made substance that is not at all what I'm talking about, right? It does include silicon in its structure, right? Silicon, oxygen, hydrogen, carbon, and those types of things. But that's synthetic and comes with a whole bunch of baggage with that. So silicon can be a very common element in nature. We can find it in sand or quartz. But the trick regarding plant nutrition and utility in nature is the silicon has to be plant available, right? And so silicon dioxide, which is commonly in the sand and quartz, it's not very plant available. Maybe over long periods of time, certain microbes or whatever may break it down into more usable forms, but that's probably more of I would think, an extremely slow release, fertilizer, if you want to think of it that way. So, as I said, we want this to be plant available. And so, it has to be in a specific form. Whether the silicon is in the form of silicic acid or monosilicic acid, right? Those are going to be able to be picked up by plants and be able to be used by plants ultimately. So, the silicon, when in this form, can be very useful to plants and can provide a bunch of different benefits. Some of which may be from the physical presence of the silica, where the plants uptake that silica, jettison it to their cell walls, and that's where we can find potentially some reasoning for how silicon makes these plants less susceptible to diseases and insects. So silicon is a very hard mineral. It's very tough, very abrasive, and it can wear things down over time, right? You look at quartz or you look at sand, they're not really water soluble at all. They're just very tough. They maintain that toughness in nature in many ways, in many forms, right? So that's kind of how we want to think about silica and how it can kind of relate to some of these insects and pests, is that it really helps strengthen those cell walls of those plants. And it makes that plant material less accessible, less digestible to insects. It may even wear down their mouth parts over time, or for whatever reason, the insects will tend to consume less of the plants that have a higher silicon content. Also, enhancing that cell wall with the silicon can also make pathogens less able to infect the plant right from the outside. An article that I have linked down in the show notes of this video mentioned a couple of things, right? Powdery mildew, like in cucumbers, may have a reduced effect or not be as effective in infecting the plant when these plants are fertilized with silicon, right? Also, anthracnose in tomatoes may also go down, right? So even some of these plants, such as tomatoes, that don't generally take up a whole lot of silica compared to other plants, such as rice, for example, you can still see benefits in silicon treatment in these plants. And then silicon can also help to increase plant immunity by biochemical processes, right, such as increasing certain plant secondary metabolites, like certain types of phenolics, phenolic compounds, flavonoids, etc., or maybe alkaloids, whatever the case may be. And some of these secondary metabolites can have like bitter or astringent qualities, but they can also be distasteful or not healthy for certain types of insects, right? These are natural compounds in plants that are produced, at least in part, for natural pest control or for self-defense, to make them less attractive to different insects, or also better able to fight certain pathogens, right? Sometimes these secondary metabolites can be very healthy for humans and be medicinally effective, right? Because they can also fight pathogens and help keep us healthy in some ways, right? So it kind of makes sense that there's that relationship there. When we're talking about this, what also can kind of relate to it is that silicon can also help to enhance or contribute to or help to modulate certain immune pathways in plants, right? We can talk about the salicylic acid pathway, which is not to be confused at all with silicic acid or monosilicic acid. Salicylic acid is basically aspirin, right? It's completely not related, not the same thing at all, but it sounds very similar, so really try to not mix them up. And then silicon can also help to kind of modulate and work with the jasmonic acid pathway in plants. And so these are defense pathways in plants to help keep them healthy and help to decrease plant stress, or the effects of plant stress. So we talked about the biotic resistance. We also have some abiotic factors, right? So these are going to be weather related, not necessarily related to organisms or life forms, but stresses caused by weather events, climate. We can have certain types of mineral imbalances in the soil that can cause or contribute to plant stress, right? We can have heavy metal contamination, or we can also have salt salinification of some of our soils, and salt in too high of a quantity can cause plant stress. In very, very small quantities, sodium can be is important for plants. It can be beneficial, but oftentimes it's a nutrient that we have to usually worry about having too much of, as opposed to not enough, especially over time. So silicon may compete with some of these minerals to be taken up and used by plants preferentially instead of these other minerals or metals or salts. And then we also have some compelling findings that silicon may make some plants more drought resistant as well, right? And that can be a huge plus for a lot of times in agriculture. Obviously, if there's not enough rain, or it gets really hot and dry for a long period of time, that can cause negative plant stress. It can be widespread throughout a region. So this may be a really interesting angle of one more tool in our toolbox that can make our plants a little bit more resistant to that kind of stress. One other note that I want to really impress upon here is that silicon is not just necessarily beneficial for plants, right? But it may also have beneficial effects on humans as well. Obviously, I'm not a doctor or a health practitioner or any type of dietitian, but silicon may have some benefits for bone and teeth growth and maintenance, and it can have some other potentially beneficial effects in the human system as well, right? So when we're fertilizing or being mindful with making sure our plants get enough silicon, understand that it may also have farther reaching effects, such as being beneficial to our health potentially as well. So there are some different sources we may be able to get silicon in for our plants. The effectiveness of these may vary widely, may not be fully established, but as we continue to move forward, hopefully maybe we'll be able to get some more clarity on that, right? But these are some kind of rudimentary ideas here. Of course, we have the marketplace preparations of, you can type in online and have all kinds of different options for silicon emphasized fertilizers. The effectiveness, again, of course, who knows? I haven't tried any of them specifically, but those are options, right? And of course, we'll want to keep in mind that of the different types of forms that silicon can be used in by plants, or what forms they can be into that can be easily converted into these forms in the soil profile, or whatever the case may be. And then we also have rice hulls that can accumulate a lot of silica, but it may take time for that silica to be released into the soil profile and picked up by plants. And then we also have potentially diatomaceous earth. I'm not sure how much more, it may be slightly more bioavailable to plants than in sand, but diatomaceous earth may also be a source of silica, right? Of silicon. And so we might want to maybe make sure that we have a robust and healthy functioning soil microbiome that's cycling nutrients and stuff. And if we can add a little bit of whatever this may be, and then that can kind of add into that whole process. Thank you so much for checking out this video on silicon and how it's useful and how we might be able to use it to be able to give our plants more silicon. And it's a mineral that may also be beneficial and important for human health as well. A lot of this information is relatively new and we're still building upon it, and I'm sure we have a long way to go with understanding silicon's utility and importance in plant health, and even follow that into human health as well. But in the meantime, thank you so much for checking out this video, and I look forward to seeing you in a future video. Take care.